Switching is an essential programming concept that allows developers to control the flow of execution based on the values of variables. In this session, we are focusing on using enum literals with switch statements. By the end of this tutorial, you will understand how to enhance your code structure using enums in various programming scenarios. So far, we've covered the advanced usage of unions in programming, specifically how they can infer enum tag types and encapsulate methods. We've discussed managing multiple data types effectively using enum tags for clearer state management, in addition to integrating methods within unions to improve organization and functionality. These techniques promote an object-oriented approach in procedural contexts, making code more intuitive and adaptable. Now, we will talk about how we can implement switching using enum literals to streamline our flow control and enhance code readability. Now let's see how we can implement a switch statement using our defined day of week enum to determine activities based on the current day. In this example, we first assign the value for today to be day of week, Wednesday. Following that, we use a switch statement to evaluate the value of today. Each case of the switch corresponds to a different day of the week, and we provide an activity for each day. For instance, if today is Sunday, the assigned activity will be relaxing. On a Friday, it will be potty. This use of shorthand notation with before each case improves readability, allowing us to focus on the values rather than the enum type itself. The selected activity is then printed with a debug statement, clearly indicating what we plan to do today. This method enhances organization by associating specific behaviors with clearly defined states, which not only makes the code easier to read, but also improves maintainability by ensuring you can effortlessly adapt or update activities in the future. Now let's see how we can implement a switch statement using enums to manage actions based on the days of the week. In the code, we start by defining an enum called day of week, which includes named constants representing each day. This approach not only makes our values more readable, but also prevents mistakes that could arise from using plain integers. We specify today as day of week, Wednesday indicating the current day. Next, we create a switch statement that evaluates the value of today. Instead of using the full enum type in each case, we can leverage the shorthand to express our case values, making the syntax cleaner and easier to read. Each case corresponds to a different activity, relaxing on Sunday, working on weekdays, and various weekend activities like pottying and hiking. Finally, the selected activity is printed using the standard debug print functionality. This method of using enums with switch statements offers a structured and intuitive way to manage flow control in our application, enhancing both clarity and maintainability of the code. Now let's take a look at how we can expand our enum to include additional values and enhance our switch statements functionality. In the updated code, we introduce a new value, holiday, to our day of week enum, which represents a special day. This change emphasizes the importance of exhaustive switching, a feature that mandates coverage of every possible enum case in a switch statement. In the main function, we set today to day of week, holiday. The corresponding switch statement aims to assign an activity based on the value of today. However, we notice that the case for holiday is intentionally left out. This omission is crucial for demonstrating the exhaustive switching feature. Since we haven't accounted for holiday, the compiler will raise an error, prompting us to address the missing case. This mechanism fosters discipline in coding by ensuring that developers consider all potential states. Thus, as we manage states through enums, we encourage thoroughness and attention to detail, which ultimately leads to more robust and maintainable code. Now let's delve into an example of using labeled switch statements in our code. This structure allows us to improve flow control by utilizing a label for the switch statement, which can be particularly helpful when managing multiple states within a program. In this instance, we define an enum called command, which encompasses various states: start, stop, pause, and resume. We set an initial state with the variable current state starting at command start. The switch statement is then labeled as command, allowing us to jump back to this point based on the current state. Within the switch cases, we implement specific behaviors associated with each command. For instance, when current state is command start, the program prints a starting message and transitions to the command pause state using the continue command statement. This continues the execution flow in a clear manner, reflecting the ongoing state transitions. Conversely, other cases such as command pause and command stop either end execution via break or manage state appropriately, demonstrating how labeled switches can aid in organizing complex logic while maintaining code readability. Now let's implement the following example using inline switches to determine the RGB values for different colors efficiently. In this code, we define a color enum with 4 possible values: red, green, blue, and yellow. This establishes a clear and descriptive way to represent colors in our program. Next, we select a color by assigning color, green, to the variable chosen color. Instead of using a traditional switch statement with potentially multiple lines of branching logic, we use an inline switch. Here, each case is prefixed with the inline keyword, allowing the compiler to generate separate branches for each color in a single expression, thus optimizing performance. As we process the chosen color through the inline switch, the corresponding RGB value is assigned to the variable color value based on the chosen color. Finally, we print the resulting RGB value to the console, displaying it in hexadecimal format. This approach not only simplifies the code but also enhances its efficiency, showing how inline switches can streamline flow control while handling enums in a clean, readable manner. Now let's take a look at how we can use ranges within switch statements to classify age categories effectively. In this example, we start by defining a variable age with a value of 20. The core of our implementation is a switch statement that evaluates the age variable against several defined ranges. Each case corresponds to a specific age group, such as 0 to 12 for child, 13 to 19 for teenager, and 20 to 64 for adult. By utilizing ranges, we can neatly encapsulate these conditions without needing multiple individual comparisons. To handle cases that don't fall within the specified ranges, we use an underscore as a catch-all, which in this case categorizes anyone aged 65 and older as senior. This structure not only optimizes the code but also enhances its readability, making it easier for developers to understand and maintain. Finally, we utilize a debugging print statement to output the determined age category, showcasing how the switch statement simplifies classification based on the value of the age variable. This approach is beneficial when dealing with numeric data or categories, making your code more readable and maintainable. Now let's implement a function to handle responses using enums and switch statements. We begin by defining an enum called status, which represents 3 possible outcomes: success, error, and unexpected. This structure provides better clarity compared to using raw integer values. Next, we create a function named handleResponse, which takes a parameter of type status. Inside this function, we utilize a switch statement to manage different response cases effectively. As we examine the switch statement, we can see that each case corresponds to a specific enum value. When the response is success, it prints a message indicating that the request succeeded. Similarly, if the response is error, it communicates that an error occurred during the request. When the response is unexpected, it notifies the user of an unexpected response. Importantly, we've included an else case that employs unreachable to signify that any other responses should not occur, reinforcing safety by catching unforeseen outcomes. Lastly, we set up a test to validate our handling of each possible response by calling the handleResponse function with all enum values. This ensures comprehensive testing of the function and guarantees that every path is correctly executed, ultimately leading to a more robust application.